Hey everyone, today we're going to go on this incredible journey right under our feet. I want you to think of this as a little flip book of our planet, and we're about to open the very first page. So you ready? Let's get into it.
So let me just ask you this. What if everything you've ever seen, everything you've ever known, existed on a layer that's actually thinner than the skin on an apple? I mean, really think about that for a second. The entire Earth is an apple, and all of human history, every mountain, every ocean, it's all just on that super thin skin. It's kind of wild, right? Well, that's exactly what we're talking about today.
All right, so let's flip to that first page in our little geological flip book. It's time to get to know this incredibly thin, but oh so important, outer shell.
So what is the crust, really? I mean, the official definition is that it's the outermost and thinnest layer of the Earth. But you know what makes that so mind-blowing is that last part. It's where all known life exists. That's us. That's, well, everything. It's not just some layer of rock. It's literally our home.
Okay, so we keep saying it's thin, but what does that actually mean in the grand scheme of things? Let's flip the page and put some numbers on this, shall we?
So yeah, just to really hammer this point home, you've got all these layers making up our world, right? The crust, the mantle, the outer core, the inner core. And out of all of them, this one is by far the skinniest. And here it is, the punchline. The crust makes up, get this, less than 1% of the entire Earth's volume. Less than 1%. Suddenly that whole apple skin thing feels incredibly real, doesn't it?
But here's where it gets even more interesting. Even inside that tiny 1%, things are not all the same. Look at this. The crust under our oceans, it can be as thin as 5 kilometers. But the crust that makes up our continents, whoa, that can be up to 70 kilometers thick. That's a huge difference.
And that massive difference in thickness introduces us to the two very different personalities of the Earth's crust. So let's turn the page and see just how they stack up against each other.
Okay, so on one side, you've got the continental crust. This stuff is thick, and super important, it's less dense. This is what our continents are made of. Then, on the other side, you have the oceanic crust. It's way thinner, yeah, but it's also a lot denser. And that difference in density, that's the whole ballgame. Think of it like a big block of wood, that's the continent, floating higher in water than, say, a heavy rock. That's the ocean floor. It's literally why the continents stand tall.
All right, so we know there are two types, and one's thick and light, the other's thin and heavy. But what are they actually made of? Let's flip the page and look at the recipe for our planet's skin.
So the main ingredient for both types of crust is this family of minerals called silicates, which that's just a fancy way of saying rocks made mostly of silicon and oxygen. But then the recipe splits. Continental crust gets a big dose of lighter stuff, like aluminum. Oceanic crust, though, it's loaded with the heavier elements, like iron and magnesium, which is exactly what makes it so much denser. See how it all connects?
And if each type of crust had like a signature rock, this would be it. For the continents, you've got to think granite. It's the rock that makes up the core of so many of our huge mountain ranges. And for the ocean floor, it's all about basalt, that dark, heavy rock you see from volcanic flows. Two very different rocks for two very different jobs. Okay, for our final chapter in this little book, let's bring all this geology back home. Because the crust isn't just a static, boring layer of rock. Oh no, it is our living, breathing, and constantly moving foundation. Which brings up a pretty fair question, right? We've talked about how it's thin, what it's made of, but so what? Why does this thin shell of rock matter so much in our day-to-day lives? Well, it turns out it's kind of everything. I mean, the crust is the platform that supports all life on this planet. It's the pantry where we get our soil, our minerals, our fossil fuels. And it's the artist that sculpts every single landscape we love, from the highest peaks to the deepest valleys. It's the whole stage for life. And here is maybe the most incredible fact of all. This crust, it isn't one solid piece, not at all. It's actually shattered into these giant interlocking puzzle pieces. We call them tectonic plates. And the craziest part? They are always moving. So how in the world do they move? Well, they're literally floating. Yep, floating on top of the mantle, which is this layer of semi-molten rock just below. You can picture the mantle like a very, very slow-moving pot of thick soup, and it's constantly churning, carrying those plates along for the ride. Now just imagine these massive, continent-sized puzzle pieces scraping past each other, crashing head-on, and pulling apart. All that friction and movement builds up a truly insane amount of energy.
And when that energy finally gets released all at once, that's when earthquakes happen. It's one of the most powerful reminders we have that the ground we think of as so solid and so stable is actually anything but.
And all of this leaves us with one last really fascinating thought to chew on. The world map that you know, the one you see in classrooms, that's just a snapshot in time. Since these plates are always moving, it just makes you wonder, what will Earth look like in another 100 million years? What new continents will be born? What oceans will disappear? It's just an amazing reminder that our planet's story is still being written, one tiny little movement at a time.